Hello, welcome to 14.2. Today we're going to continue looking at our chi-square distribution. And first we want to say that we have used two samples of procedures. We want to compare proportions from two different groups. Now we will need another test if we want to test more than two groups. Now the question we're looking at here, does background music influence wine purchases? So what they did is they took and played no music, French music, or Italian music, and they looked at the amount of wine bought, whether it's French, Italian, or other, and they want to see if playing music has any effect on people's purchasing. Now, the first thing we need to do is look at a conditional distribution. Now, remember conditional distributions. We're going to do this in percentages for the column. So if I look back here, so out of 84, we'd want to do each of these numbers out of 84. So 30 over 84 is 0.357. So let's say it's about 0.36. 11 out of 84 is 0.13. 43 out of 84 is 0.51. So take a second and fill in the rest of the distribution and pause the video. Alright, hopefully you've found all of those values. And if you look here, here is the conditional distribution for playing no music, French music, and Italian music. Now, I was just going to round to no decimals, but over here there was a round-off error, which made it impossible for those numbers to add up to 100. So I just decided to carry it up to one more decimal. Now, we could, if we put these in good graphs, we can look at the graphs and see if we can see any major differences right away. So when they played no music, it looks like other wine was the top sellers, and French and Italian wine were a little bit lower. When they played French music, almost nobody bought Italian, so it was just French or other, and French wine sold much more. When they played Italian music, Italian wines went up, and these two went down. But Italian music definitely didn't go up more than the other two, or it didn't sell as much as the other two. All right, so to do this, we need a chi-squared test for homogeneity of populations. So to do this, we have to select independent SRSs from each of C populations and classify each individual in the sample according to a categorical response variable with R possible values. There are C different sets of proportions to be compared for each population. The null hypothesis is that the distribution of the response variable is the same in all C populations. The alternative hypothesis says that these C distributions are not all the same. So if the null hypothesis is true, the chi-square statistic has approximately x squared has approximately a chi-square distribution with r minus 1 times c minus 1 degree of freedom. So this is much different than before. So 1 minus the rows and 1 minus the columns. We have to multiply those two things together to get the degree of freedom. So if we went back to this, the totals don't count in that. So we have 3 rows, 3 columns. So we subtract 1 from each of that, so that's 2 and 2. So here our degree of freedom is 4. Alright, so let's get to it. To do this, we do an expected count. We take our row total times our column total and divide it by n. Now you can safely use a chi-square distribution. We've already talked about it having to come from an SRS, or at least a random sample. You can safely use a chi-square to test with critical values from a chi-square distribution. We know where the 20% of the expected counts are less than 5, and all individual counts are 1 or greater. In particular, all 4 expected counts in a 2x2 should be at least 5 or greater. But that's just in a 2x2 situation. So perform a chi-square test to see if music has an influence on wine sales. Well, first let's write a null hypothesis. Our null hypothesis will be that the distributions of wine selected are the same for all three populations of music types. So, so the distributions of wine selected are the same in all three populations of music types. So our alternative hypothesis is the distributions of wine are not the same. Alright, so now let's go from go to the conditions. And did this say that the data comes from an SRS? I don't think I wrote anything about the problem really. So I got this problem from the book and I just didn't write out all the words, but this data does come from an SRS. Now, the second part of our conditions, we have to know all of the expected counts. So we need to go back and figure out expected counts. So let's go to conditions or calculations first. And then we can get the expected counts from there. All right, so I brought up the data here, and if we want to find the expected counts, what we do is we take the column total times the row total divided by n. So if I wanted to figure out the French, I do 84 times 99 and divide it by our n, which is 243. If I wanted to find my Italian total, I would take 11 times, I would take 84. Hold on 1 minute. All right. So what we do is we take, for Italian, we would take 84 times 31. Now all over 243. And for other, we would do 84 times 113 over 243. Now I figured out all of these numbers on my calculator, and the values are 34.2, 10.7, 39, and the French I got 30.6, 9.57, and 34.9. And now for Italian, I have 34.2, 10.7, and 39.1. All right, now how we figure out our values is now we do the same thing we did with the goodness of fit test. We take our observed value, which is 30, minus our expected value of 34.2, square that, and divide by our expected value of 34.2. Now we add to that our next value, say 39 and 30.6, so we do 39 minus 30.6 squared over our expected value of 30.6. Now you continue to do this, and so on, for all 9 of these values. And when you do that and you add them all up, you get a chi-squared value of 18.28. Now, we do the same thing. Once we get our chi-square value, we do the same thing. We put our chi-squared into our chi-squared CDF. We're going to go 18.28 to a very large number. And we use our degree of freedom here, which was 4. And I got a p-value of 0.001. So now we have to interpret this. So since our p-value is low, we reject the null hypothesis because the p-value is low. So now we have to write a conclusion. So we have to write a conclusion that says playing music has an effect on which wines customers purchase. All right. Now, when we get a value, something like that, we should always do follow-up analysis in the real world. And AP stats, generally, we're just done. But we should always look and find out what exactly is wrong or different in that situation. So that we just found out that there's not a connection like we anticipated, but we want to figure out what the correlation will be. All right, the chi-squared and the z-test. If we're comparing two proportions, we could use either a chi-square test or a z-test. A z-test gives us more flexibility, so that's what we did in the past when we had two proportions. We just did a two-proportion z-test. But if you really wanted to do a chi-squared, you could. But the z-test gives us more flexibility in choosing one-sided or two-sided tests. All right, hopefully that's enough to get you through your homework.